Hello viewers, welcome back to my YouTube channel. Today we are going to look at the fundamental laws of logarithm. But before we do that, I want to appeal to you to kindly subscribe to my YouTube channel, turn on the notification bell, and give me a comment and a like. Okay, that is if you are visiting for the first time. If you are a returning subscriber, please, I would really love to know what you feel about this video in the comment. Thank you and God bless you. Okay, so let's go back to why we're here today. We'll look at the fundamental laws of logarithm. We're going to look at about 10 of them. But before we do that, let me quickly give you the brief definition of logarithm. Now, the way to write logarithm is short for log, L-O-G. So for logarithm, we shorten it as log. So that stands for logarithm. And there is a very close connection between logarithm and indices. So there's a video I made and it is showing up at the right hand side. Please watch that video on indices, and then from what we're going to do today, there should be able to link indices and see the linkage between indices and logarithm. So now, by definition, if you have a number m, let's say you have a number m, and then you take the logarithm of m, okay, and then to a certain base. Now, what logarithm says is that, by definition, this a, to obtain the value of m, we must raise this a to a certain power. Let's say that power is x. So it means that if I raise a to a certain power x, I must get m. So that is what it means. So from here now, it means that for me to write this as a complete equation is going to be logarithm of m to base a is equal to x. So that once I raise a to the power of x, then it must give me the value of m. So that is the simple definition of logarithm. I hope that is clear. Now let's move on to the basic laws, or the basic or fundamental laws that are guiding the operation involving logarithm. So first, let's look at the first law. Now, if you have two numbers, m and n, and then you take the logarithm of those two, you take the logarithm of the product of m and n, that is, you have m and n. You take the logarithm of the product of the two numbers, and then you take to a certain base. The law says that we can expand this to give logarithm of m to base a plus logarithm of n to base a. So that is the first law of logarithm. That's the first law. Now the second law is similar to it, but in this case we are looking at division. If I have two numbers m and n, then m is divided by m is divided by n. Then the base is a, to a certain base a. So the law says this should be log m to base a minus log n to base a. So now let's proceed to the third law, which says if I have the base to be the same as the number, let's say, of course, we have the base a here, so that means I'm having log a to base a. Since the two numbers are the same, the number and the base are the same, then the law says the result is 1. So that means the the log of a number to its base is 1. Next, we have the logarithm of 1. Now, there's a law that says the logarithm of 1 to whatever base, whether any base at all. So once the logarithm of that number, once the number is 1, the logarithm of it to any base is 0. Then of course, we move on to this other law, which is the fifth law. Now this says that if you have m, for example, and then m is now raised to power x, you have logarithm of m. Now m is in turn raised to a power, and then you have a base a. Take it to a base. Then the law says that this power x, this x which is the power of n, becomes a coefficient to the log. So it means that x, this will become x log m to base a. Hope that is clear. Now we move on to the next law. That's number 6. So now we have seen here that this power is a whole number. What about a case where the power is a fraction? What do we have? Let's say you have log m to base a, and then this m has a power that is a fraction. Let's say 1 over x. Now the same law will apply here. So this 1 over x, which is power, becomes a coefficient. So you have 1 over x log m to base a. Then of course we move on to the next law. Now this next law deals with a case where you have the base to be raised to power. You know, just like log 5 and 6, you will see that in log 5 and 6, you have a power of x, and then in this other case, in log 6, we have a power of 1 over x. What about when the base now is assuming that power? What happens? Let's look at two cases in log 7 and log 8. In log 7, let's say for example we have log m to base a. Now this base a is now having a power p, for example, power p. Now what the law says is that because the base is carrying a power, it now becomes reciprocal. You take the reciprocal of it, and then that reciprocal of p now becomes 1 over p. So you have 1 over p. So this 1 over p becomes the coefficient of the log, log m to base a. Please don't forget, once the base assumes a power, the law says, or the rule says that take the reciprocal of that power, which is 1 over p, then log m to base a. So the power is no longer there. Now in log 8, log 8 is similar, but in this case, the base is now having a power that is a fraction. So you have log m to base a. Now this a now assume a power that is a fraction. Let's say we have p over q as the power of the base. So the same thing happens, the same principle. Take the reciprocal of it. So the reciprocal of p over q will be q over p. And that q over p assumes the position of the coefficient. So you have q over p log m base a. So that is the law. So law 7 and 8 deals with the case where you have the base now assuming the power. Now there's another twist I'm going to add to it. Now what about a case where you have the base is having a power, and then the number n is also having a power, and this time around I'm going to make the two powers to be fraction, like I have it here in law 9. You have log m to base a. Now m is raised to power, let's say x over y, and then the base A will maintain P over Q as power. So now, what does the law say? Of course, our P over Q becomes reciprocal. So you have PQ over P multiplied by the power of M, X over Y. So the two products, the product of the reciprocal of the base, the power of the base, and then the power of the number M will be their product will now become the coefficient. Then you have log M base A. So this will further give us Qx over Py log M base A. So that is for law 9. Then we move on to the last law, which is law 10. So here we are going to be talking about the change of base. This one deals with change of base. Now, let's say you have a logarithm. You have this log M to base A. Now, suppose we decide to change the base from A. Change the base from A, maybe to say B. So the law says, since we have decided to change the base, so we are now going to have log M to the new base, B, divided by log A. Of course, you know we have M and A. M is the number, A is the base. But we have now decided to change the base to a different number, in this case B. Therefore, it's going to be log of M to base B divided by log of A to base B, B being the new base. So these are the fundamental laws of logarithm. And then in my next video, I'm going to show you how to apply these laws to solve numerical logarithmic problems. Thank you for watching, and then please subscribe, turn on the notification bell, and then of course share the video and tell your friends so that they can also benefit from what you have benefited. Thank you very much, and God bless you. I'll see you in the next class.